Okay, let's go ahead and define a series. Very close connection to a sequence. So let's see it. The series is the sum of the terms of a sequence. It's when you add the terms of the sequence. So let me give you an example. We saw this sequence at the beginning of the last video, right? 2, 4, 6, 8, 10, dot, dot, dot. The equivalent series is this: 2 plus 4 plus 6 plus 8 plus 10 plus dot dot dot. If you continue to add the terms, we give that the name series. Okay. Um, well, what's the usefulness of series? There's actually way more applications for series than there are sequences. We don't really get a whole lot into the applications in this course. We really just introduce these ideas. But let me tell you, in future math courses, sequences are big. They're important, but series way more so. Okay, let's take. Um, well, we'll do an example in a moment. Um, so you might ask, like, okay, I can maybe like see the relevance of a sequence. Maybe, this list of numbers that follow an order or a pattern. Um, a series, though, I mean, especially a series like this, 2 plus 4 plus 6 plus 8, then we'd be adding 12 and 14 and 16. If we're adding all those numbers up, that's just going to add up. It's just going to get bigger and bigger and bigger, right? Each time we add another number. That's true. So that's really not that interesting in this case to think of adding all infinitely many numbers together. So instead, we focus on what we call the nth partial sum. Okay. The nth partial sum is the sum of the first n terms. So let's not think of it as being infinitely long. Let's think of it being, some finite length, like maybe 10 terms or 20 terms or something, and just add those up. So we call it the nth partial sum, the sum of the first n terms, and we'll pick the value for n in the problems. We denote this as capital S sub n, the sum of the first n terms. Okay, now let's dive into an example. We're going to find an nth partial sum for this series right here. We saw, this sequence. We saw this sequence back before as well. An equals 3n plus 5. So if you recall, let me not give away the answer too much. Okay. Now I'm thinking, did we? Yeah, we had this sequence before. We found the first 3 terms. We found a1, a2, a3 earlier. All right, so the first term here is 8. Second term was 11. Third term was 14 when we plug those numbers 1, 2, and 3 in. We want to go all the way to 6 terms because S6, right, the sum of the first 6 terms. So we find A1 through A6. And so we plug in 4, we get 17. We plug in 5 for n, we plug in 6 for n, we'll get these values. You may also notice, as you're finding each one, even after the first 3, like what's happening every time? Aren't we adding 3 plus 3 plus 3 plus 3? That 3 right there causes us to add 3 every time. Okay, anyway, that's kind of beside the point, but you notice that pattern. All right, once you have the first 6 terms, well, then we're going to add them together to find the sum. And that's what I've got right here. We're going to add 8 plus 11 plus 14 plus 17 plus 20 plus 23, adding the first 6 terms together, and well, grab a calculator for that, and you will get 93. So here, I probably should have said S6 equals 93. That's really maybe how we want to state the answer. The sum of the first 6 terms. Okay. That's just about it for this introductory section. There's just one last thing to say that I've got here at the bottom. Um, so let me, doing a lot of this covering up here in this lecture. Um, Summation notation for the nth partial sum. So this is a good thing to be aware of. It's really not something that we spend a lot of time on. We really just showcase it here in this first section so that you're exposed to it. For future math courses, it won't be brand new. That turns out it's really, really helpful if we do that sometimes. So what's happening here? Well, really, anytime you learn a new concept like the nth partial sum, there's usually a notation to learn along with it. So part of the notation is the S6. That stands for the sixth partial sum, right? There's also this that's really popular when you get into later math courses. You may recognize this symbol right here in the middle. That is the Greek letter sigma. It's a capital S in Greek. You may have seen that shape maybe on somebody's roof near SDSU, right? One of the frat or sorority homes or whatever. Okay, so sigma, S-I-G-M-A is how you say that. Why did they pick the Greek letter sigma? Well, because that's the letter S for them, and we're doing a sum. So, hence the sigma. Okay. What the heck is going on around here? So you're going to see something at the bottom. Our textbook uses I. So they pick the variable I equals 1. And then up above, they give the 6. So the 6 here would be like we're finding the sixth partial sum. Okay, that's how many terms you want to add up, right? How many terms do you want to sum? So you'll start with the first term, I equals 1. You'll end at the sixth term, and you'll add each one in between. Think, okay, what are we adding? Well, next to it, we put the sequence. So there's this set of parentheses, and then 3i, because that's the variable we're using, 3i plus 5. So here's how, now this is all looks very, very weird, but here's how it works. This means to add the first 6 terms, okay, because we start with 1, we end at 6. And how do we generate each of those? Well, we plug, we're starting with 1, we plug it in for I this time instead of n. So 3 times 1 plus 5, that came from I equals 1. Then we add, and we plug in I equals 2. We get 11. Then we add, we plug in I equals 3. And we keep going until we get to the very last one. Will be I equals 6. That's where we stop. Add all those up. And it equals 93. So it's kind of a notation that we could say this is representing the sum of 6 terms. And then we find out what those are. And so this thing is equal to that. So you're going to see a few homework problems that ask you to compute things like this. Follow this pattern. You're finding an nth partial sum. The n is up there. The sequence is here. Again, we're not going to do anything more with summation notation or the sigma in this course. We just want to introduce it to you so you've got a leg up when you go to future math courses, if that is in your future. Okay, that's the end of the section. So I wanted to leave you guys with a few problems to try out on your own. So I've got a couple here. Find the first 4 terms and the 10th term for that sequence. Find the 8th partial sum for this. And then we've got this application about Rita, who just got hired, and she's got a starting salary and she gets raises. So maybe pause the video, take a look at these. In the next video, we're going to do those together. I will see you there.